Good afternoon. I want to talk to you about a study that we're doing at 3 locations called the Farming System Study. And over the course of many years, we've been kind of interested in what maybe the comparisons of what we call conservation tillage versus no-till is for nutrient availability, because there's temperature differences and moisture differences in each one of those as the season progresses. But also when you remove corn stalks, sometimes, not always, but sometimes we can take off quite a bit of nutrients, and that changes the amount of nutrients available to the next crop because the nutrients in that stover is not available for recycling and microbial breakdown and all that sort of thing. And thirdly, we recognize that maybe in the future there's going to be some carbon credit issues, maybe in some farm bills, and maybe there'll be a little source of income if we can show improvement there. And also when corn stalks are removed for maybe ethanol production in the future, cellulosic fuel stocks and that sort of thing. You know, these are some issues that are in the kind of a horizon in the future sometime. And what we wanted to try to do is put a kind of a comparison together between tillage and residue management and that sort of thing, so that we could start to answer some of these questions. But also at the same time look at the production economics. That is, you know, do some of these systems really pay? Do they pay in short term, long term, and that sort of thing? So we wanted to put a kind of a system study together looking at combinations of some production practices. It's a 5-year study. We're kind of in the middle of it now. And the way we chose the sites was along the eastern part of the state. It's kind of convenient to have our research centers kind of spaced out. This first map is looking at growing degree days. And there's a difference between the southeast farm and the northeast farm, and about 700 growing degree day units in degrees Fahrenheit. And that translates into a couple of weeks growing season length. So we have a kind of a spread here, and so we're looking at these kinds of production practices over this sequence of growing degree days, if you will. The bottom map is showing similarities in annual precipitation, and there's about a 2 to 3 inch difference on an annual basis between the southeast farm and the northeast farm. We don't think that that's all that different. And so really the difference is in growing degree days and how the microbes have a little bit longer time to kind of break things down and that sort of thing. And we're trying to see if there's not differences in the northeast farm, southeast farm as far as the ability to retain carbon and that sort of thing because of maybe a little bit more stimulation of energy down the southeast versus the northeast. So that also, of course, impacts grain yield and the production practices, till versus no-till. No-till is a labor-saving device, but also you need to manipulate the soil a little bit with zone tillage or strip tillage in order to create an environment that's favorable for plant growth and that sort of thing initially. So there might be a little bit of input costs in no-till, but far more input costs for conventional till. And generally overall, conventional till in a normal year would yield just a little bit higher. And so there's trade-offs there, labor-saving trade-offs and energy-saving trade-offs there. So these are some things we want to factor into our economic model. Don't have any data. Last year we probably had corn yield ranges from about 5 bushels to about 25 bushels across the state, and soybean bushels about maybe 12 to 20 and that sort of thing. And there wasn't much difference there, and so I'm not reporting that data. But hopefully if this is a normal year, we're going to be able to look at some of these changes since we're right in the middle of it. And as time goes on, these changes would cause separation in responses. And that's what we see when we just compare tillage types, is over the course of the first couple of years, there's not much of a difference, but we start to see changes in the 4th and 5th year, which kind of translate into long-term kinds of situations. On the back is a plot map of the field that we're working in. It's about 7 acres. It's 2 fence rows down to the south, and it's right on the edge, right by the road. So for those of you who live locally, you're welcome to go in there and look around and see what you could see. And this is a plot map showing you where all the treatments are. And just to explain this a little bit, the top row has got the initials NT, CT, NT. That's the tillage. See that third part of the legend. So you've got blocks of no-till, blocks of conventional till, and conventional till is a chisel plow operation in the fall, followed by one field cultivation or disc or a chisel plow, depends on, in this case, what Al has hooked up and that sort of thing. So it's kind of minimum till, if you will. It does a good job of disturbing the soil down to about 4 to 6 inches, and that's kind of what we're after, is that kind of disturbance. The plots are about 200 feet long and 12 rows wide, both for soybeans and corn. So we plant them in 30-inch rows. The darker shaded rectangles here are plots in which the residue for corn has been removed. In this case, in 2013, you see plot 105, 108, 201, et cetera, et cetera. So you're welcome to go in there and see if you can see any differences. I will tell you that the conventional till growth stage is about a half a leaf to a leaf ahead of the no-till for both the corn and the soybeans. Whether that translates into yield or not, we're just not sure. Generally, though, things kind of wash out a little bit because about the middle of and the end of July, Mother Nature turns the faucet off. So there's a little bit of moisture savings in a no-till, and that seems to kind of fill the grain a little bit more than a conventional till. So it kind of evens itself out. Even though you might have early growth in this spring with conventional till, you may not get the yield translated into a yield advantage. So economically, though, if you get similar yields with similar or with no-till compared to conventional till, you're really a little bit ahead economically because there's a little bit more input costs to conventional till. So we want to try to work these things out in the next couple of years and present you with some models and look at some of these comparisons. Okay, any questions? Yeah, good. Okay, you've been very patient. Thank you for your time.
Are you going to track just the yield, or will you take into consideration these input costs?
Good question. Yes, we're documenting input costs, and in addition, now that you've opened up the door, we're also looking carbon dioxide flux. We have got collars in each of the plots, looking at how much carbon dioxide is coming off, and we are sampling the soil every 2 years, 0 to 3, 3 to 6, 6 to 9, and 9 to 12 inch increments, and tracking what happens with carbon and phosphorus and zinc over those times for each of the plots. So
I'd like to see you carry that on further than 5 years, because our experience with no-till, it takes about that long to get it going.
You're exactly right.
The soil working.
The and that's to get that first 5 years and get our foot in the door with some funding that's the place to start. Oftentimes these funding agencies, they don't like to give you a lot of money for a long period of time. And so what we're hoping is that maybe we can parlay that into something a little bit longer term, and that's a really good point you bring up.
One thing you talked about savings on input. One big savings is time.
Mm-hmm.
You aren't cultivating or working the ground, just go out and plant it.
Yeah.
Sure, you might have to spray
Yeah.
more often, but
Yeah.
most people pre-emergent spray and then they come and spray once or twice again anyway, so that's about a wash. But
Yeah.
if you don't have to go out and till that ground, you're saving quite a bit of time
Yeah.
to go plant.
And interesting enough, for those of you who like to travel and have visited other countries, there's some countries in Eastern Europe in which their population is declining, and so they don't have the help. And so they're rapidly converting to no-till in Ukraine and southern Russia and that sort of thing, because they just don't have the guys to get out there to work the fields. And that's the big draw of no-till right now. That's the big selling point. And you know, they're a little bit ahead on their energy saving also as
Yeah.
well. Good.
Don't
Well-
don't need as big a tractor as all you're
No.
doing with the planter. You
Yep.
don't have to pull that big chisel plow.
That's true. Thank you, and appreciate you coming out to the tour.